Welcome to Study Loop.
In this problem, we get to be forensic scientists and figure out, using science and math, when someone was murdered. So this is a Newton's law of cooling problem, and if you read the section of the book, you notice that Newton's law of cooling is based on the same kind of exponential growth and decay equation, y equals y naught e to the kt, derived from a differential equation. And we can replace y for this particular kind of application with T minus T sub s, where T is the final temperature of the object, T sub s is the temperature of the surroundings. And we can replace y naught with T naught minus T sub s. T naught is the initial temperature of the object, and T sub s is still the temperature of the surroundings. So for this problem, we know the temperature of the surroundings is 20 degrees Celsius. And we're also told that the body temperature goes from 32.5 degrees to 30.3 degrees in 1 hour. So we can use that piece of information and our model and solve for K. So let's plug those numbers into our model. So we have 30.3 minus 20, final temperature minus surrounding temperature, equals 32.5 minus 20, initial temperature minus surrounding temperature, times e to the k times 1 for 1 hour. Okay, let's go ahead and simplify this and solve for k. So we end up with 12.5. Oops. Let's back up a second here. We end up with 10.3 equals 12.5 times e to the k. Then we divide both sides by 12.5, and we have 0.824. So 0.824 equals e to the k. And then we take the natural log of both sides, and that gives us k. All right, so we put that into our model, and we now have t minus 20 equals t naught minus 20 times e to the natural log of 0.824 times the temperature. So we're going to use that model to help us figure out the time of death. Okay. So this is the point where we utilize the information that normal body temperature is 37 degrees. So we're going to assume that when the person was alive, their body temperature was 37 degrees. That's going to be our new T naught, our new starting temperature. And we want to find out the time difference between that temperature and when the temperature of the body was 32.5 degrees at 1:30 p.m. So let's use 32.5 as our final temperature. And let's use 37 as our initial temperature. And we're going to substitute that into our equation and solve for T. Okay, so we have 12.5 equals 17 e to the natural log of 0.824 t. We can divide both sides by 17, and we end up with 25/34 equals e to the natural log of 0.824 times t. And then we're going to take the natural log of both sides. So we have the natural log of 25/34 equals the natural log of 0.824 times t. Now to get t by itself, let's divide both sides by the natural log of 0.824. And then this whole expression goes in the calculator, and we find the approximate value. Now this gives us approximately 1.59 hours. If you convert that into minutes, you get 1 hour and 35 minutes. So that tells us that 1 hour and 35 minutes before 1:30 p.m. was when the person was murdered. So 1 hour and 35 minutes before 1:30 p.m. is 11:55 a.m.